Hello, this is Nitin Dahad with the Times. I'm talking now to Bill Chappell, who's the CTO of the Microsoft Discovery and Quantum group at Microsoft. Bill, hello, how are you?
I'm great, and thanks for allowing me to join.
Well, thank you. You've been quite busy over the last couple of months. We met at the Design Automation Conference, DAC, in San Francisco, and then you've had a couple of conferences last week. But before we go there, just tell us a little bit about what you do at Microsoft and your background and the group you're running.
Yeah, thanks. I am the CTO and VP for a new wing of Microsoft called Microsoft Discovery and Quantum. So really think of us as a bridge to new products from the great research that we do and sort of the scale products that we create at Microsoft. How do we make sure we have fresh new products like a quantum computer? That'd be one of the primary focuses of our team. We just announced a Microsoft Discovery product, right, which is really the intersection of AI and science or AI and design, where discovery is the heart of the new capability that you're trying to create.
And you've been with Microsoft for a few years now.
So I actually started as an academic at Purdue University, then joined the government, ran an office at DARPA, really focused on next generation hardware, the Microsystems Technology Office. Joined Microsoft about 6 years ago. Developed, originally was the CTO of Azure Global, which was our translation of the cloud to new product sectors like Azure Space. We created Azure Space as a new sector for Azure, how to extend the cloud into satellites and into the International Space Station as examples, but then did a bunch of interesting work on how to utilize the cloud differently. Then we created Microsoft Discovery and Quantum, and it's really the formalization of how to create new products. The difficult part is going from sort of the invention phase into something that has a scale need and a scale product motion, and so that's what our team specializes in, why it got stood up as sort of a novel capability within Microsoft.
In the last couple of weeks, you had Black Hat and then DEF CON.
Yep.
Just tell us a little bit about the things you've been announcing and seeing, observing there.
Yeah, that's great. So a couple of things. I think things are moving very fast. So at DAC, we announced some of the new discovery capabilities that we have, and now have a blog and a paper that's out as well describing that. And that's for really long-running agents that understand the scientific method. And if you understand the scientific method and that's your thought pattern, the agents can then follow how a scientist would approach a problem and then bring the human along and vice versa, so that they're working together on what the discovery process is. Done wrong, you just press a button and hope the AI comes up with a result, and you have to accept it. Done right, it's truly a collaboration where the agents are exposing their weaknesses, saying where they're having to make critical decisions, asking the human what type of critical decisions they should be making, and the approach that the scientist would take to solve that same sort of problem. And so that's the basis of the Microsoft Discovery product, which was announced, and we showed some demos of that at the Design Automation Conference. We believe it's going to be very important for science. It also will impact the design community as well. You similarly want to use long-running agents to simplify the tasks, but only you can do that if you have the right collaboration points and the right control from the human over the agent operations.
And at Black Hat and DEF CON?
Black Hat and DEF CON, very similar. We announced something called Project IRE, and that's for our security and cyber teams. The same basic concept of taking agents that are being used in domains that the models have some knowledge of but aren't experts in. And so you have to build tools, you have to build knowledge bases that are the deterministic backbone for how the agents behave and how they then enter into a novel domain. And we showed Project IRE, which has very good performance, 90+% identification of malware. Now, in parallel, the government ran a program for autonomous cyber reasoning systems as well, and the intersection of AI and cyber. And so it was great to kind of see our capabilities released, but also then they're validated that the government is seeing very similar things. And now you have open source variations of these same type of reasoning systems that have found a very large number of vulnerabilities in open source software, as well as things that will impact critical infrastructure. So I think we're turning a corner from things that look interesting to actually are proving themselves. There's really three competitions that happen in parallel at DEF CON. One is the sort of human teams for CTF, and they're many problems which only humans can solve, and these are the world's best, and they get in teams and they now use LLMs for specific parts of their functions, but for the most part it's a human driven competition. There's something called live CTF, which were smaller competitions, and that's a round robin sort of human on human competition historically, and a autonomous system entered in and actually did beat the humans in a round robin format. And so that is, I think, a important moment. And so, paying attention to that was something that, I'm reflecting on it myself. Like, what does that mean when you have the ability of these very, some of the world's best hackers that, in an open competition were, struggled to compete with, an autonomous reasoning system. Now, at the same time, then you had AICC, which was built for autonomous systems. And that also showed, I think they were up around 80% in being able to capture these synthetic vulnerabilities that were created. So they went from like 30% last year to roughly around 80% this year, which is a huge leap in performance. And they also found 18, which weren't actually, implanted. They were actually, just vulnerabilities that have been sitting there inside of that software. And so that to me, speaks to the value of a challenge problem. Back in the day, even before I joined DARPA, we did the Urban Grand Challenge, which was, can a self-driving car drive from LA to Las Vegas? What people forget is the first year the answer was no. And cars went about a mile. Many of them burned up because they didn't know how to stop when they kind of hit a rock or hit a berm. The next year they did cross the finish line. And so I think something very similar just happened. And that's really important for the cyber community. More importantly for me, I think it validates, some of the, and puts truth to, where the capability is from hype to, some of the cynicism that exists. Like it's, obviously it's somewhere in between usually. And the government did a really good job of just kind of showing where we sit today.
It does raise a lot of issues around how we need to capitalize on AI and humans working together, and the agents and humans working together. I think that's quite important for you, isn't it?
It is. And, I think that's the basis of our discovery product is, how do you do that in such a way that the human, is ultimately accountable for the result. And, I think the models are getting better and better, but, again, disenfranchising the end user, right, is in no one's interest, including us. So good product design will be asking the right questions of the human, right, being able to expose the weaknesses of the agents, being able to say, I don't know, right, which is something that, AI is not great at today. And so how do you make sure that they're answering the right types of questions that they should be asked to do, and so that the human can do the part that only humans can do, and the agents can then amplify that capability by doing a lot of autonomous reasoning.
And what's the thing that you think, the work you're doing, and sort of more the broader societal challenges? Where do you think you're helping that?
So I think building a product for discovery. So right now AI is very good at repeating what it's seen. Once you have to aggregate information from many different sources, right, and have a novel opinion or a novel discovery, that's where it gets much harder. And whether it's just novelty or it's just assimilating from very, very large corpuses of data that are beyond what a human would be able to assimilate, it can come up with opinions that are non-trivial. And so how do you do that and make sure that the human is brought along and actually validating that is a valid new opinion, right? And so that is, I think, the next leap in the use of AI, and not just regurgitating the things that are in your inbox or in your data store, but suggesting where new discovery and new invention can happen. And go ahead.
So what do you think people are missing when they're talking about AI and sort of these autonomous reasoning systems and getting to AGI?
Yeah, I mean, I'm not sure how useful that term is, but no, it's a great conversation. But I think it's ultimately useful already. And it become more useful, and sort of you're always going to have a human machine collaboration, right? The question is, what's that shift, right? And I think the machine, as it gets smarter, is going to do more of the work, but that can't be done in such a way that it's just passed off to the machine and we just watch and accept answers, right? So again, how do you get to that level of true collaboration so it's a real partner? It's a trick, right? I mean, it's a challenge in that it's non-trivial, right? Because over-reliance on the AI is a human failing, but it's also human behavior. When you see it is able to perform things really well, you just sort of pass that responsibility off, right? So the good product design is required to be able to make sure that sort of over-reliance is not happening and that you're using the agents the right way. One thing we just released is what we call a cognitive loop, right? Which is building the scientific method into the oversight of the agent operations. So how you think about a problem is now instantiated in the agents. And so when it's off course, right, it could be flagged and the human, brought in appropriately. So it thinks more like a human, or it acts more like a human. The human can control the decisions that are being made, and then step in, at the critical times when they need to step in to support the agent network. And so that's the basis of the discovery product. But it's more of a something that's going to happen, I think, domain by domain, where we figure out this human machine balance.
Last question then. You talk about domain by domain, but what sort of domains have you seen some real examples of application where you think, wow, this is why this is important?
Yeah. Well, I think the most public now, as of last week, is in the cyber realm. And, we always, really in 2014, and when I was at DARPA, we created the Cyber Grand Challenge with the knowing that you just can't throw humans at the problem, that it won't scale. The number of things you need to be looking out for is going to be beyond what you can do just with humans alone. And so, that's actually now coming to fruition like a decade later. And so there's obviously software engineering that's going through a pretty radical shift in what can be done to create a system quickly. We are starting to see that happen in science, and then obviously autonomy would be the next frontier, where these agents now are operating with physical objects. So you can kind of see from software today through domains like biology, chemistry, and physics, through physical operations. You can see where that roadmap looks like. And I think agents aren't overhyped, but they're also have to be done right. So there's so many startups that are doing agents, which is great, a ton of energy in the community, but the models themselves are not going to be the answer. They're part of an answer, and they're the thing that's pacing a lot of these new capabilities. But you then have to bring in the domain expertise and the experts, to shape how that they operate. And so whether it's the discovery framework or any of the others that are being built, right, it is a combination of human expertise on top of the model expertise, which will give you the type of capabilities which got announced over the last month or two.
Man-machine collaboration.
Yep. Now it's at an up level. That's absolutely right, and that's been talked about for years. What I think is the distinction is now you're looking at 3-hour running, long-running agents, right? Okay. We've done something recently for 10 hours, and at the output of that is a new vaccine candidate, right? And so that ability to then set up the environment with the right tools to then be able to say, here's the vaccine candidate that vaccine candidate needs, right? And here's the parameters that we're looking for. Doesn't mean you just instantaneously create a vaccine, right? It does mean that you get new ideas that can then be vetted, very quickly. We did something similar on new battery development with PNNL. That was announced last year. That was kind of the beginning of our journey. So new batteries, new drugs, new physical objects, new circuits, right? Those are all sort of now in play, where the balance of machine-human interaction has, I think, radically shifted in the last couple of months.
Well, Bill Chappell, thank you very much.
Thank you.